Welcome back. This is the wrap-up of 1.4's video, so sometimes I will continue a video because the other one is getting too long and it's not. I like to try to keep the videos all under 10 minutes if at all possible, so you'll never have one that's longer or too much longer than 10 minutes. So this one's just continued. We're going to do example 2 and example 3 and then go from there. So you should continue these notes right from where you left off before. Example 2 is writing prime factorization. So my directions just simply state write the prime factorization of 48. So I'm going to start with picking a factor of two factors of 48 that would work. I could pick 2 times 24. I could pick 3 times 16. You can list out all the factors and choose from there if you'd like, but any of them will work. You'll get the same end result. So let's just go with 2 times 24. 2 is prime, so I circle it. Then I have to move on with 24. What times what equals 24? I can pick anything. I'm just going to keep going with the route I'm on and do 2 times 12 because I know 2 is prime. So again, I circle any prime numbers. Now I've got 12. I know that there's more than one factor pair in 12, so I'm just going to do 4 and 3. And it doesn't matter what side you put your prime factor or your prime numbers on. It doesn't matter at all. 4 is not prime because 2 times 2 equals 4. And then that ends my tree right there because I can't go any further. Those are all prime numbers. So again, when you list them out, you're going to list them below. So I just made this smaller and moved it aside so that I could draw this and you could see what I'm doing here. So I'm going to take all my numbers that I have circled, all my prime numbers, and I'm going to list them out. So 48 equals 2 times 2 times 2. Notice how I'm crossing them out as I go. It makes it a lot easier when you're trying to keep track of them. Times 2 times 3. Then I can look back and I can notice that I haven't missed any because every single one of them has been accounted for. Okay, now, as I said before, I'm not finished. I've got all of these numbers spread out like this, but I can notice that I've got the same bases. So what I'm just going to do is I'm just going to put a box around the same numbers. I drew 4 boxes. So what that means is I've got a base of 2, and because I have 4 2's, 4 becomes my exponent. Then I also have a 3 that's its own separate box, so I have to add that one in there by putting it multiplied by 3. So this would be my final answer of the prime factorization of 48 would be 2 to the 4th power times 3. Rewind the video, go back if you're having troubles understanding it. I'm going to show you another one in just a moment. So example 3 is just using prime factorization again, and I'm going to be very honest with you. This is tricky to understand. Listen carefully, pause, rewind, figure out what you're missing, or jot down a question that you may have to ask in class of something you didn't understand. So, the question is, what is the greatest perfect square? Okay, we're looking for the perfect square that is a factor of 1,575. What is the greatest perfect square that is a factor of 1,575? So we need to find the factor. Okay, we're not just looking for the perfect square or we're not asking is 1,575 a perfect square. We're asking for the greatest factor of it. So this gets a little tricky, but we can use prime factorization to figure it out. So what we're going to start with is writing out 1,575, and we are going to factor this out. So because 1,575 has many factors, it's not efficient to list all the factors to check for perfect squares. Remember, a perfect square is a number multiplied by itself, and that number that, or the product that it equals, that would be a perfect square. So for instance, 5 times 5 is 25. That's a perfect square. 6 times 6 is 36. That's a perfect square. So we're going to use prime factorization of 1,575 to find any perfect squares that are factors. So what we start with is we have to use some type of factor. Or I'm sorry, we have to use two factors to start with, because we're going to do a factor tree. Well, what could two of them be? You could easily divide this out by a number, see if it comes out. Use your divisibility rules. Okay, obviously 5 would work because the ending number is 5. You could go that route if you want. I'm just going to quicken things up a little bit. We're going to start with 25 and 63. Because 25 times 63 does equal 1,575. 25 nor 63 are prime, so we have to keep going. Let's start with 25. 5 times 5, and those are both prime, so we circle them. 63, we have 7 times 9. 7 is prime because nothing can go into it but 7 times 1. We can move on with our 9 by saying 3 times 3, and those both end up being prime. So now we could jot this down as 1,575 equals, remember, 5 times 5 times 7 times 3 times 3. That's what our prime factorization would equal. We'd actually make it 5 to the second power times 7 times 3 to the second power. So now that we've figured this out, it shows that it has 3 factors other than 1 that are perfect squares. Because I noticed that if it's a perfect square, it's going to look like this, right? What are those actual perfect squares? Well, what you have to do is you have to pull those out together. So it's going to look like this. Let me go to a new page. Okay, I just made it smaller. This is where it gets tricky. So follow with me, okay? So what I do is I'm going to look at it from right here. I've got 2 perfect squares. I've got 3 times 3 equals 9. That's a perfect square. 9 is a perfect square. Then I have 5 times 5 equals 25. That's a perfect square. However, that might not be the greatest perfect square of 1,575. So what you need to do is you need to take, okay, now let's follow with me, 3 times 5, that's what I'm using, times the other side of that perfect square, 3 times 5, okay, which ends up equaling 3 times 3 is 15, 3 times 5, I'm sorry, 3 times 5. 3 times 5 is 15, 3 times 5 is 15. 15 times 15 ends up equaling 225. So what our information's telling us by finding the prime factorization, that the greatest perfect square that's a factor of 1,575 is 225. Now this is the trickiest part right here, is finding out how do I do this. So you've got to match them up. You're playing a matching game here, okay? 3 times 5 is 15. 3 times 5 is 15. And you also might realize that if I actually just took 9 times 25, I'm still going to get 225. I'm just breaking it up for you so you can see where these perfect squares are coming from. Okay, now you're on to the try it portion of the video. What I do is I usually do 1, 2, 3, 4-ish, and somewhere in there, the very end of videos where you need to try it on your own, and you write the prime factorization of the number. You pause the screen, work on it, and then I give you the answer on the next screen. So make sure you pause it, give it a try, and then you'll see the answer, and that completes the video. Here's the answer for number 1. Should have 3 squared times 2 times 5.
And the answer for number 2, prime factorization of 462 equals 7 times 2 times 3 times 11. Remember, you're multiplying, so these can be in any order. I do prefer that you do it in order of the numbers of how they range, so just a kind of a heads up. All right, this concludes the video.